Whoa. How did that happen? Are we there yet? Hold on, we gotta fix that. Unstable. All right, well, one of these is working, at least. If I do this. Oh. That's working. All right. How's it going, y'all? Picking up where we left off. Learning Rust. We're gonna do some of this, some of that. Rust programming language. Boom. Learn. Is the book in here? Read the book. Boosh. Are we? There we go. Awesome. Let's open up a terminal, huh? Let's throw this over there. Make that a little bit bigger. Not big enough? Oh, maybe we should do this. Plotting. All right. Cool. All right, picking up where we left off. So, did not want that to be full page. Full screen. That's fine. Installation, I can start there. All right, hello world, cargo. Rust up. Let's see, programming Rust. Hello world RS. Okay, cool. That's fine. They can live there. Why is that? Okay, there we go. Cool beans. Anyways, so if you're using Rust up on Linux or Mac, blah blah blah, blah blah blah. Installing Rust up on Windows, troubleshooting. We're not doing Rust up. Hello world. We did that last time, so we're gonna make a directory project. Sure, yes. Can projects, CD projects. Hello world is there, yada yada, we made it. Print hello world, run it, blah blah blah. Anatomy of a Rust program. All right, I guess we can start here. So, function main. These lines define a function named main. Wow. Main function is special, is always the first code that runs in every executable Rust program. Here's the first line declares a function named main, and there's no parameters and returns nothing. If there were parameters, they would go inside the parenthesis. Function body is wrapped in that. You know what we're missing? Tunes, right? I need some like non-copyrighted material. Odyssey. Sure, I guess we can do that again. Why not? And we're gonna bring that down. Rocky Road, Rocky Road. Again, ambient mode, YouTube. Just saying, doesn't need to be there. Ever. Alright. So an empty main function, you know, will return nothing. Surprise. Automatic formatter tool, Rust format. I believe it's built into Cargo, so whenever you use that, it'll automatically format your program and stuff. The body main function holds the following code. Hello world, yep, it's in our hello world script there. So watch, one little secret, cat. Cats are pretty cool, right? If we cat hello, oh, I got a CD quick. If we cat hello world, boosh, whoopsie. That's what you get when you cat out a compiled program. Wait, oopsie. What is going on? Did I break it? Alright, we're gonna exit that. And we're gonna bring it back up here. So, he got angry, so we're gonna do that. CD programming Rust ls. If we cat helloworld.rs, because it is uncompiled, you can read the contents of the file. Little hacker code right there, little secret. Alrighty. If you want to stick to standard style across Rust projects, you can use an automatic formatter. We already talked about that. Print line calls a Rust macro. If it had called a function instead, it would be entered as print line without the exclamation. Oh, didn't realize that was there. Cool. We'll discuss macros in detail in chapter 20. We're on chapter 1. Hello world string. We know it's a string because we gave it a string. Yep, cool. Compiling and running are separate steps. Okay, so Rust C, we compiled it. That's how we got this, right? We did Rust C. Rust C compiler. Rust compiler. Hello world.rs. Right? And that's how we got the hello world compiled one. Okay, cool. On Linux, Mac, OS, PowerShell, you can use executables. Yep. By entering ls into your shell. So ls is short for list. We're listing the contents of this directory. Shows the source code of the file, rs extension, the executable file main exe. That's what that is. Boom. On Windows, but main on other platforms. See, I was onto something last time, so I said exe will show up on Windows. So that's how you'd run it. Or main exe on Windows. Right? Yeah. So if we run it, it would here just wow, it prints that out amazing. Where's Cargo? Here we go. Here's the bread and butter. Cargo. Cargo is Rust build system and package manager. Beautiful. It has its own package manager. Most Rustaceans Is that what that is? Yeah, that's what we are, Rust stations, programming Rust. Use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call those libraries in your code that your code needs dependencies. So if your code is dependent on a library, you should probably package it with Cargo, send it when you publish your program. Cargo is pretty cool. In Python land, it would be pip. So you got pip install requests or whatever, some magic language, not language, library. You can do beautiful soup, pip install beautiful soup. Cargo is basically the Rust version of that. So the simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. Yo, if you're enjoying what content you're reading here, reading, viewing, watching, whatever, absorbing with your eyeballs, you can like, comment, subscribe, join the channel, be a part of this beautiful mess that is going on. So, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. If you start a project using Cargo, adding the dependencies will be much easier to do. Good to know. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by running the following program. By entering the following in your terminal, whatever. Cargo -- version. Wow, we got it. 1.85, rocking out right now. If you see a version number, you have it. If you see an error such as command not found, look at the documentation for your method of installation to determine how to install Cargo separately. Good to know. We got Cargo installed. If you don't, you should install it. If you're on Fedora, you could probably do sudo dnf install Rust, and I believe it will come with Cargo pre-installed because that's how I installed this last time, right? I believe so. If you are on Debian or whatever, we'll sudo apt, right? Whatever your package manager. Got on Windows, God bless your soul, because I can't do it. Creating a project with Cargo. Let's create a new project using Cargo. Alright, we're gonna cd into projects. There's nothing in here. It's empty. Cargo, new project. We're gonna call this Hello Cargo. Dope. Creating binary application. That's crazy, because I can't read binary. cd hello cargo. There's a cargo file here, cargo.toml, and a source. Can we cat cargo? What's in there? Cargo name, alright. Oh, the name of the package. Version 1.0, added. Edition 2024. I think we're in 2025, but... no problem. The first command creates a new directory and project called Hello Cargo. We've named our project Hello Cargo, and Cargo creates its files in a directory of the same name. Go into Hello Cargo directory and list the files. You can see that Cargo has generated 2 files in one directory for us, a cargo.toml file, and a source directory with main rs file inside. We'll cd source ls main rs cat main. Boom. There's Hello World once again. We didn't even have to type any of that. We could have just said Cargo new and it would have given us. That's nice. It has also initialized a new Git repo along with git ignore. See, I did mention that. I was like, Cargo also is going to do Git for us, which is beautiful and awesome. If you don't know Git, We will learn it in the future. I promise I will make a video on it. We'll go through that. But Git is a versioning system software tool to keep track of history and records of your projects going forward. Where were we? With a git ignore file. So if you can't see your hidden file directory in Linux, you'll type ls tech la and it will show cd ... Can I ll? Yes, but it doesn't have the hidden whatever. Any file with a period in front of it is hidden by default in Linux. So if you want to be super secret and hide all your stuff, just name it. You do make dir, right? Dot hidden underscore file. And there you go, you got a hidden file. Moving forward. It is also initialized a new git repository along with git ignore file. Git files won't be generated if you run cargo new within an existing git repository. You can override this behavior by using cargo new -vcs -vcs equals git. Version control system equals git. That'd be my guess of what that means. Note, git is a common version control system. There it is. You can change cargo new to use a different version control system or no version control system by using the VCS flag. Run cargo new -- help to see the available options. So for you newbies that don't know this, most stuff has help attached to it. So you'll say, if we do cat -h, cat -f help, there we go. It will tell you how to use the command most of the time. You want a more in-depth thing, we'll take a look at man pages, and we can man cat or any other file. And this is the literal write-up of the entire cat thing, everything you can do with it. Everything explained in great detail. So cat's pretty simple, there's not a lot here. There's lots of different commands that have a lot more. But moving on. Open Cargo Toml with your text editor of choice. Vim. NeoVim. Nano if you're a weirdo. Just saying. Or, if you're on Windows, I would strongly suggest using Notepad. So that's all you need in Windows, just a Notepad. Anyways, yeah, so we did cat this out earlier. We go right there. See, this package here, got that right there. Let's clear this so it looks a little nicer, huh? This file is in the Tom's obvious minimal language format, which is Cargo's configuration format. I believe Docker container files are also in Toml. The first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines serve the configuration information Cargo needs to compile your program. The name, the version, and the edition of Rust to use. We'll talk about the edition key in Appendix E, wherever that is, probably down here or something. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. There we go. We won't need any other crates for this project, but we will in the first project in chapter 2. So we'll use this dependencies section then. Now open source.mainrs and take a look. Boom, we already did that. Function main, hello world, we already did that. Dope. ls cd source cat main. There we are. Or vim main. There she be. Cargo has generated a hello world program for you, just like the one we wrote in listing 1-1. So far, the differences between our project and the project Cargo generated are that cargo placed the code in the source directory, and we have a cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using Cargo helps you organize your projects. There's a place for everything, and everything is in its place. Okay, good to know. It's in its place. If you started a project that doesn't use Cargo, we did the Hello World project. You can convert it to a project that does use Cargo. Move the project code into the source directory and create an appropriate cargo toml file. One easy way to get that cargo toml file is to run cargo init. So we're going to initialize it with cargo, which will create it for you automatically. You can also use git init if you're using git. Yeah. Lots of things are parallels in programming. They go together. So if you pay attention, learning one hard language will probably teach you a lot about other languages. Building and running a cargo project. Okay, we're going to build this bad boy. We're going to quit out of that. Now let's look at what's different from when we build and run the Hello World program with Cargo. Wubba-lubba-dub-dub. Alright. Build your project by entering the following command. Cargo build. Do we need to be in this directory? cd hello. Cargo build. Okay, cool. Worked. So, this command creates an executable in target debug hello cargo, or target debug hello cargo.exe on Windows. Okay. Creates an executable file in target, so probably my current directory, debug hello cargo. Oh, target right there. Duh. Rather than in your current directory, because the default build is a debug build. Cargo puts the binary in a directory named debug. You can run the executable with this command. Target debug hello cargo. Remember from last time, tab complete. So we have, source target here. So if you // we're going to run a program. We're going into the folder target, T, tab. Okay, what is also in target? You can press tab again. Oh, if there's nothing else, if there's only one option in there, it will auto paste it. But if there's many options, see like that, it will list out your options if you double tab. And then you would just say debug. We're already in debug, and we're going to hello cargo. There we go. And boom, we're running it. Hello world. Cool, we did it. If all goes well, hello world should print to the terminal. It did. Running cargo build for the first time also causes Cargo to create a new file at the top level, cargo.lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have any dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. Thanks, Cargo. Everyone say, thanks, Cargo. That's great. Alright, we just built a project with Cargo build and ran it with run. But we can also use cargo run to compile the code and then run the resultant executable all in one command. Cargo run. Hello world once again has popped up. Finish dev, unoptimized, debug info. Compiled in 0.00 seconds. Man, that's fast. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use cargo run. Notice that this time we didn't see any output indicating cargo was compiling. Hello cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild, it just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it, and you would have seen this output. Compiling hello cargo, right, our project, version 1, and then running hello world. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles, but doesn't produce an executable. So if you're running a large project and want to quickly just check it, run cargo check. Why would you not want an executable? Often cargo check, we're going to explain this now, is much faster than a cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rustaceans run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we've learned so far about cargo. We can create a project using cargo new. So you'll do cargo new and then project name after it. This could probably be a large string of characters or names, numbers, whatever you want to call it. We can build a project using cargo build. Sweet. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores it in the target's debug directory. In addition to advantages of using cargo, is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. Building for release. When your project is finally ready for release. You can use cargo build -- release using the release flag or option, whatever you want to call these things, to compile it with optimizations. This command will create an executable in target release instead of target debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development, where you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark with the executable in target release. Cargo as a convention. With simple projects, cargo doesn't provide a lot of value over just using Rust compile. What it will provide is worth as your programs become more intricate. Once programs grow to multiple files or need dependency, it's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using git. There we go. Change to that project's directory and build. Git clone. Okay. Some project. cd to some project and run cargo build. So eventually I will link this repo and repos or whatever to like GitHub, a GitHub repo. So a GitHub repo is essentially that's what it is. It's an online repo on the web. So if your repo is public, anyone can go on there and they can copy it themselves and then run the project. So if you have multiple people working on the same thing, you can say, hey, here's my code. Take it for yourself, try it out. You can go into the source code and build it out and blah, 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 blah. Do collabs or free and open source software. It's FOSS. Remember, baby, it's FOSS. All right. For more information about cargo, check out its documentation, or you can buy a book called The Cargo Book, or something like that. I don't know. You're already off to a great start in your Rust journey. Blah blah blah, cool. Level 2, programming a guessing game. Wow, we're going deep right now. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let and match, methods, associated functions, external crates, and more. In the following chapters, we'll explore ideas in more detail in this process. In this chapter, you'll just practice the fundamentals. Cool beans, cool beans. Alrighty. We'll implement a classic beginner program problem. A beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer, which is a number between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high, or if the guess is correct, the game will print out a congratulatory message and exit. Cool beans, let's clear this. Where are we in? CD. Alright. New project. What are we gonna do? We're gonna say cargo, new. Guessing game. Here we go. Buy the book. Boom, we're creating guessing game. CD into guessing game. CD source, and we're gonna vim main. Wow. Okay. Cargo new. Just did that. Cargo toml. Yeah. Don't need to know that. In the main. Now let's compile the program. Okay. Sorry, we're getting ahead of ourselves here. CD, ls, CD guessing game, cargo run. Oh, is that what we're doing? Yes. Cool, it's compiled. Now reopen source main file. You'll be writing all the code in this file. Yes, I will. Clear. ls cd source vim main. Boom. Do we need this? I guess we can leave it. We're gonna delete 3 words. Oops. Click to S. Oh my goodness. There we go. Insert. Guess the number. There we go. Let's do this. Yank. Put. Oops. DD. Put. Dang, I wanted it there. There we go. Alright. Delete 3 words. Insert mode. Yeah. Someday I'll become a good Vimmer. Please input your guess. So, we're printing out these statements to the console. And now we are declaring let mute, not caps, let mute guess. We're declaring a variable, a muted variable, so it means it doesn't change. Called guess, we are declaring it as a string value. New. Wow. We're calling input output as standard input. Read line. And mutt guess. So here we are assigning guess to this readline function. So readline, I believe, is we're prompting the user for input, and we are inputting that what input we get to the variable guess there. Expect Failed to read line. So if we have an error or something, will be printed out to the screen. Why is my formatter not working? Let's put... Oh, I did not want that. Insert, tab, print, line. Yeah, why is my stuff not coming up? Because we're in regular Vim. Alright, hold on, let's try this. So let's right quit. nvim main. Alright, boys. There it is. Boom, print line. Alright. So in case you didn't know, you could run Vim and nvim on your system. Just like I was right there. And when you forget what system you're in, makes for funny stuff to happen. You guessed this value. And so these curly brackets here, right, is a placeholder for our variable we're gonna called guess. Oh, it needs to be behind the quotes. Okay. This is still a placeholder. And we're gonna go guess. There we go. Okay, let's write it. So if you had multiple variables, I believe you could add another set of curly brackets here, and then you would have guess, and I believe another comma here, and then you would add the second variable name there, or whatever. But let's hop out of here, quit right quick. So we put all this in with a little bit of variation. All right. This code contains a lot of information. Let's go over it. To obtain user input and then print the result as output, we need to bring the IO, input-output library, into scope. That's what we did right here. Whoop-a-lubba-dub-dub. The IO library comes from the standard library, known as standard. Standard library. Cool. Use standard IO. Wait. Oh, did we not put that in the... Okay. Sorry, I missed that in the top. So we're going to import this standard input-output by going nvim main rs. So if you didn't know, you could look up your commands history by using the up and down arrows. So it'd be like, hey, I ran this 2 times before, 3, 4, 5, 6. And you can set like your history limit to what, 100, 500, 1,000 characters, or infinitely in your bash rc file. But anyways, nvim main. We are going to insert right here a couple of spaces. Use standard IO. There we go. Now we're gonna right quit that. Now we got use standard IO in there. Okay. The IO library comes from the standard library, and the standard, we got it. By default, Rust has a set of items defined in a standard library that bring into the scope of every program. The set is called the prelude, and you can see everything in it in the standard library documentation. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Using the standard IO library provides you with a number of useful features, including the ability to accept user input. Yeah, that's what our program is doing. As you saw in chapter 1, the main function is the entry point into the program. The function syntax declares a new function. The parentheses indicate that there are no parameters, and the curly bracket starts the body of the function. As you learned in chapter 1, println is a macro that prints the string to the screen or the console, wherever it's running. I guess this program could run on the screen, probably like the monitor you're watching this on. This code is printing a prompt stating that the game is that's stating what the game is and requesting input from the user. Wow, words are hard. Storing values with variables. Next, we'll create a variable right there. Let mutable variable guess equal a string new to store user input like this. Now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples equal 5. Right. Can do lots of stuff there. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning that once we give the variable a value, that value won't change. We'll be discussing this in chapter detail in the variables immutability section in chapter 3. To make a variable mutable, so that means it's able to be changed, we add mute before the variable name. Note that the / syntax starts a comment. A comment is just like reader's notes in a book. Like, say you bought a book from the library and someone scribbled in there like some notes, be like, oh, this is a good part of the book. There's your comment. That's what your comment is. They're for developers to read and communicate to each other. Typically, there's nothing good read from comments, but they're there if you want to put them in there. They can be used for your own notes, for your own sanity. Be like, hey, I don't know what I was doing here, but it's crazy code below. Yeah, we'll talk more about comments in chapter 3. Cool beans. Returning to the guessing game program. You know that let mute guess will introduce a mutable variable named guess. Equal sign tells Rust that we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. Okay? String is a string type provided by the standard library that is growable. That is a growable UTF-8 encoded bit of text. So, when we are declaring this variable and calling a string value, I believe we are requesting a space in RAM to put this variable in and for the program to read out faster now. UTF-8 is an encryption of our variable, so it's going to be encrypted somewhere. And 8 is the length, so there's UTF-8, 16, blah blah blah, and it goes up higher more. Whatever. Just melting your brain with a bunch of extra facts. The double colon syntax in the new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type, in this case string. This new function creates a new empty string, and you'll find a new function on many types because it is a common name for a function that makes a new value of some kind. In full, let mute guess equals string new line has created a mutable variable that is currently bound to a new empty instance of a string. Receiving user input. Recall that we included the input-output functionality from the standard library in the top. That's where we declared it. On the first line of the program, now we can call a standard in function from the IO module, which will allow us to handle user input. Cool. If we hadn't imported the IO library with use standard IO at the beginning of the program, we could still use the function by writing this function. Hold up. If we hadn't imported the IO library using the standard IO at the beginning of the program, we could still use the function by writing this function call as standard IO standard in. Okay. Standard in function returns an instance of standard IO standard in, which is a type that represents a handle to the standard input for your terminal. Next in line, read line, mutable guess, calls a read line method on the standard input handle to get input from the user. There we go. We're also passing mute guess as an argument to readLine to tell it what string to store the user input in. So we're requesting for user data. We're putting that into a string. We're storing that string as the variable guess, which is also a string. The full job of readLine is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be immutable so that the method can change the string's content. The AND indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory, there we go, multiple times. Cool. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use a reference. You don't need to know a lot about the details to finish this program. For now, you'll need to know that, like variables, references are immutable by default. Hence, you need to write and mute guess rather than end guess to make it mutable. Okay. Cool. So when you write something into memory, how the computer knows how to get that back out of memory, it has a little beginning tag. It says, it's like a library column or something. It's like, hey, this variable guess is in section G, and that's a hex bit of code, and that's your read. So just a little fun fact for you, I guess. Handling potential failure with result. Cool. So yeah, here we're working with this line of code. We're now discussing a third line of text, but note that it's still part of a single logical line of code. The next part is this method. Expect failed to read line. We could have written this code as input, output standard in, read line, and mute guess, expect failed to read line. That's a lot. However, one line is difficult to read, so it's best to divide it. It's often wise to introduce a new line, another white space, to help break up long lines, when you call a method with the method name syntax. Now let's discuss what this line does. Okay. Read line puts whatever the user enters into the string we pass to it, but also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of the result types is to encode error handling information. Right. Results variants are OK and error. The OK variant indicates that the operation was successful. Dope, that's what we want. And it contains the successfully generated value. The error variant means the operation failed, and it contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. Any instance of result has the expect method that you can call. This instance of result is an error value. Expect will cause the program to crash and display the message that you passed as an argument to expect. So if you're taking input and the computer doesn't know what input it's getting or something, then it's gonna say, hey, check this out, we don't know what's going on. And it crashes your program. It displays the error code, hopefully. The instance of result is an OK value. Expect will return the value OK, and program should just continue on to the next step. So if you didn't know, a program typically goes top down. Well, I guess that's not always true, but sometimes it's true. If you don't call expect, the program will compile, but you'll get a warning. Okay. Sure. Printing values with print line placeholders. Okay. Aside from the closing curly bracket, there's nothing more. Rust warns that you haven't used the result variable from readline, indicating that the program hasn't handled the possible error. The right way to suppress the warning is to actually write error handling code. Sure, can do that later. Oh no, I don't want to do that. Shh, come back. Wow, we're a long ways away. Alright. Aside from the closing bracket, there's one or more line to discuss in the code so far. Print line, you guess. Alright. This line prints the string and now contains user input. The set of curly brackets is a placeholder, right? I think of this as little crab printers that hold the value in place. When printing the variable of variable, the variable name can go inside the curly brackets. Okay. When printing the result, when printing the value of a variable, the variable name can go inside the curly brackets, but our variable is empty. When printing the result of evaluating an expression, place empty curly brackets in the format string. Then follow the format string with a comma separated list of expressions to print in each empty curly bracket placeholder in the same order. Printing a variable and the result of an expression in one column print line would look like this. Let x equal 5, let y equal 10, print line. X equals x and y equals y plus 2 equals that, and so y plus 2. Right. This code would print x equals 5, y equals 2. Testing the first part. Finally, get into the good stuff. Cargo. Wait. Do you have to go back one? I think so. I don't know. Should be able to run it in there. Oh! It wants us to guess a number. Please input your guess. What if we put a string value, right? Like ASDF. You guessed ASDF. Wow. Cool. Later in this program, we will set up checking for the number and stuff and change the string to an integer and blah, blah, blah. All right. So now we know we're getting input. Here, let's run it again. Cargo run. Input your guess. Hello. I am giving you input and some numbers as well. You guessed. Boom. So, cool. It's a very long string, but it's still a string nonetheless. Okay. What time we got? We're cranking this thing out. Cool beans, cool beans, cool beans. What do you think? Should we call it a night? Keep on going. Guess the number, read line. Just guess. Maybe we could speed run this. Yeah. That's alright. We've been streaming for about an hour here, so might be a good spot to take a break. Generating a secret number. Alright. So we're getting more into here. Let's go to serious mode. We're getting more into finally writing out our programs. We got through cargo, knowing our stuff there, our projects and our music and stuff too. So, where are we? Cargo, Rust programming. So we're getting through chapter 1 here, nice and slow like. We can start going, picking up the pace in a little bit. I'll be streaming here Wednesday nights at 7 or 8 p.m. Central Standard Time. And that is my goal to stream as often as possible there. then still going good. So I also have a YouTube channel. Follow me on YouTube, PCmoses. I'm streaming on Twitch and YouTube at the same time, but I will continue to upload videos on my YouTube channel, and that's where you can find, yeah, video content. I just recorded a video about setting up a home lab, and we go into like hardware and that stuff like that. So planning to have that out by Friday, so look out for that. And yeah, it's PCmoses here, trucking on through Rust and uploading videos. If you hop onto my Twitch channel, under the About Me page or whatever, I got, list of my equipment that I'm using and, I don't know, a little bit of fun README crap. It's in there, I guess. Oh, I have a donation box if you want to give me money. That'd be cool. But, it is what it is. So, yeah, just let me know if you guys want any more information about the channel. Got a lot of knowledge up here about computers, programs, languages, networks, firewalls, hacking stuff, IP addresses, packets, lots and lots and lots and lots and lots of stuff. DevOps stuff, programming stuff, all the above. I've done some 3D printing too, so if you guys have some questions on that, we can do 3D printing stuff like 3D design. Yeah. Yeah, if you want some video content, hop on over to my YouTube channel. I will be uploading there more frequently as I can. But yeah. So, thanks for coming, watching my stream. I don't know what else to say. Thank you and good night.